just so you're aware, for the schedule, we flipped, since the Starliner happened, we flipped the AMA around Kim's hour. So your AMA will be next time.
Okay. So can you hear me okay, Kim? Okay, I'm still working apparently on getting your... You're good. I can't hear you though. Hold on. Yes. And now... Oops, I pressed the wrong button. Can the world hear you? This is the question. No. Hold on just a second while we figure out what's going on. All those things are working. Let me add one more audio feed. I think it already has it. New audio. Can you say something again?
Hello, world. Hello.
Okay, we now have you, just very softly.
Oh. Should I move my microphone?
Rigel has a good point.
I'll drop my gain, and yes, if you can move your microphone. Together we shall find the same audio level.
I'll try and speak a little bit louder. I'm on a slightly different microphone than usual.
And in a different location, it looks like, as well.
Yes, I'm in Cleveland this week.
Okay, well, welcome to Cleveland. We have a lot of good community members and good friends of CosmoQuest up in Cleveland, so I can say no wrong about that city other than its weather.
That's true.
We have you on to discuss the news, and we actually had a breaking news alert that caused you to come on a little bit late. So,
I was asleep. What happened?
So the Starliner capsule that failed to enter the correct orbit came down early and just successfully, we think, landed in White Sands. Because it is still dark in White Sands, New Mexico, we were looking at everything in infrared, but all through parachutes deployed, it went thunk in the way you would expect a spacecraft to go thunk. So now we're waiting for confirmation to come to us from Boeing that at least this piece of the mission went as planned.
Yeah, I hope so. It was kind of really startling that, it didn't, like, after all this, the SpaceX stuff always going so perfectly.
Right.
Like, we've gotten so used to that, like having the Boeing, the Starliner not go into the correct orbit was like, I remember when this used to happen all the time, but it's been a while.
Well, and one of the things that intrigues me is all of the news about this has been the first American-made capsule made on American soil by Americans.
Mm-hmm.
And I understand that Elon Musk was born in South Africa, but I'm not entirely sure how I feel about Boeing trying to basically play the America card when SpaceX is in California.
Right? I mean, it's an American company. Right?
Yeah.
I don't know. I always assumed it was. And, like, I always consider people who were born in other countries and come here and have lived here and make a living here and start businesses here Americans. So.
Yeah.
Right? I don't know.
Yeah.
I think the chatter I was hearing on Twitter yesterday was mostly about how, given how Boeing handled all the media around the launch and how much less open it was than SpaceX. How much, I guess, journalists preferred the SpaceX version of let's just show you everything as it's happening. Like more transparency than what Boeing was doing. I don't know. I was traveling yesterday, so I didn't keep full up with the news. Oh, there you are. Hello.
Yeah, sorry. I just realized you didn't have my video. And is there an audio problem? Is the audio good now? Okay, I think we're good. Yeah, we have a thumbs up. Everything is good. Oh, no, still 2 live mics on Pam. How do I have 2 live mics? You're good. So, can you give us a highlight of all your favorite news stories from this week while I work on figuring out how I have 2 audios?
All right. So last week, well, the week before, I was at AGU's fall meeting, which is the largest geoscience conference in America. There were like almost 30,000 people there, and I was covering it as a reporter, so there was so much news going on. And then the week after that, I was totally sick and not paying attention to anything. So my last week was really 2 weeks ago. So some of my favorite things from that week, which maybe we've talked about before, there were some really cool highlights, obviously from OSIRIS-REx picked its landing site, and I was super excited about that. Um, I was Team Nightingale the whole time. I'm just going to say I picked the winner. My editor was Team Kingfisher, and she lost. Sorry. But I was Team Nightingale.
Kingfisher was so small. Well, I understand that sentiment.
Just lost Kim.
Okay, we just lost your audio. Hold on. I'm trying to figure out what I just did wrong. Can you say something again? I am going to beat the equipment for a moment. Say something again?
Hello, hello.
Okay,
Hi,
it just
Pamela.
needed to be turned on and off for some reason.
As all good technology does.
I am so sorry, folks.
That's
So
okay.
sorry.
Yeah. So OSIRIS-REx, we were all very excited to see the landing site. I was really surprised to see that even within the landing site, there was such a small area within that landing site that was deemed acceptable. It was something like the size of 10 parking spaces, which is crazy small. That was like they showed a graphic of the full crater is pretty small on Bennu, and then they zoomed in to Nightingale. And
Yeah.
within that crater, they overlaid like the 10 parking spots with one car, and they were like, that's OSIRIS-REx. And they have to be it. That was just a really startling, but a great way to display just like how precise they really have to be. And then they showed the stereo image of Mount Doom looming over the crater, which I just love that they called it Mount Doom for one, informally. But
yeah. And I don't know how much you've been following along with Bennu Mappers here at CosmoQuest, but we were not expecting this many rocks.
yeah.
We wrote our software, we trained humans, all using data from Itakawa, which is a similarly sized asteroid. But it's one coherent piece. It kind of looks like a cashew. There's some nice smooth areas on it. And the typical 450 pixel by 450 pixel image at the resolutions that we were getting of Bennu, I would have like a few dozen rocks on them, under a dozen boulders, maybe 1 or 2 craters. No big deal. Yeah. The average image of Bennu, the rubble pile a-hole that it is, had hundreds of rocks, dozens of boulders, and maybe a crater that we could distinguish in all of that mess.
Yeah, and so with all the mapping, like you guys and the team have been able to map pretty much all the boulders. I think they said down to like 10 centimeters in size, which is just phenomenal. Like just to start with, that's a heck of a lot of boulders. 10 centimeter boulder, whatever. But the graph can only pick up stuff like at 2 centimeters in size. And all of that is still completely unresolved. Um, and
And
there's just so little of it,
And this
even
is where the
within like the
craters
best
become
spots.
so important, because if you noticed, all 4 of the potential sample sites were
Hmm.
craters.
Yes.
And so the way I look at it is these are places where a incoming space rock acted like a mortar and
Mhm.
ground away at a section of the surface to make one area dustier and flatter.
Yeah, and I think what they were talking about is that because the rest of the surface is essentially just like big boulders, there's lots of cracks and crevices between all of these boulders. So any smaller fine grained material has probably gently sunk in, trickled down through all those cracks and crevices, and made its way underground over time. Even if with Bennu's weak gravity, it'll happen eventually. So that's maybe why they think that all the fine grained material is only found in these new craters,
Well,
which,
and they're also having so many issues with Bennu throwing things.
yeah, it's throwing stuff. That's just crazy. I call it the Bennu and the Jets because it's just that's Bennu.
It's the one of the best cartoons I saw describing this, and then we'll get to there's some questions in the chat that I'll get to. One of the best cartoons that I saw about this was Hayabusa 2 arrives at Ryugu and proceeds to bomb it. And Ryugu calls out to Bennu and goes, "Oh my god, I'm under attack." And Bennu essentially fires up its weapons,
Yeah.
and those are
Like,
the
I got
rocks.
you. I got you.
Yeah, yeah.
Yeah, I saw that one. That's awesome.
Now we have in the chat. I see One Love IPFS is asking, where do rocks in space come from?
Where do
So
rocks
so
in space come from?
how do how do we get um how do we get a rubble pile like Bennu?
Well, it all starts a very long time ago in our own galaxy. Sorry, I'm in the Star Wars mood right now.
It's
So
fair. It's
I
fair.
got I
I'm
got my
after.
Star Wars Christmas sweater on. I got my Star Wars coffee mug. I'm going to see it tonight. Got it on the brain. Anyway,
Oh,
it all starts about 4.5 billion years ago, right here in our own solar system. The sun forms. It sucks up a lot, pretty much 99% of all of the hydrogen and the helium that uh, that it was allowed to have. It sucks it all up in the middle, but there's still a bunch of stuff left over, including a lot of things like carbon and silicon, iron, magnesium, the heavy stuff that the sun doesn't really want. And it's swirling around in a disk around the sun, this very young sun. And slowly but surely, they coalesce into tiny little dust motes. And then those dust motes coalesce into little pebbles. And those pebbles coalesce into bigger boulders about a meter in size. And sometimes those little meter-sized rocks will glom together into larger clumps, and those clumps can sometimes make planets, but more often than not, they don't. And we just happen to have a ring of all of these never became a planet rocks between Mars and Jupiter. That's the asteroid belt. And some of those get knocked out, and some of those fly around and hang out with Jupiter. But we just have all this leftover material from when the solar system formed that never became a star, never became a planet, never became a moon. It's just hanging out around there and has been basically since our solar system was born. That's where all these rocks come from. Uh, Sometimes those rocks crash into each other, they fly apart, they coalesce back together. And that's what we think some of these rubble piles are, just, loosely glommed together things of rocks that maybe will fly apart one day, maybe won't, but we think have basically been there since the sun has.
and one of the cool other possible ways you end up with a Bennu, this hellscape of rocks, is if you have just the right energy collision, you can shatter the objects involved, but not disperse their matter at too high a velocity. So all of this stuff basically shatters in place and comes back together and holds on gravitationally. So you can go from having larger objects, and they think this is more likely what happened to Ryugu. We're still figuring out Bennu. Bennu is...
Bennu's weird.
Yeah. So with Ryugu, they have two different colored minerals, essentially, that are glommed together in a different rubble pile. And this idea that two objects hit and became one pile of broken pieces is a sad and beautiful
Also very
story.
strange. Yeah, and I think between all of the different asteroids that we're now seeing, I mean, we have Japan's Hayabusa at Ryugu. We have OSIRIS-REx at Bennu. We've been to Itokawa. We've seen other types of small bodies in the solar system. We're seeing some familiarities, some similarities between all of them, but basically they're all very, very different.
Yeah.
Like you said with Ryugu, you have two objects that came together very gently and smooshed together into one rubble pile. But out in the outer part of the solar system, we have MU69, who has a new name that I've forgotten, and I feel bad that I've forgotten the new name.
MU69 is fine.
Yeah, which New Horizons visited almost a year ago.
Yeah.
It is a combination of two objects that came together gently, but then just sort of stuck. Yeah, like a flat pancake and a squished orange. I don't know.
Yeah.
I don't know how to describe those shapes really. But they just sort of stuck together and are very clearly two separate objects that are just sort of touching right at one point.
And this is showing us that if you can imagine a scenario in which two objects will collide, those two objects have collided.
Yeah. Our solar system has millions of these things. So given all the chances, they've probably smacked together in about as many different ways as you could think of.
And that's awesome. And I want to thank Kevlar for the bits, which is also awesome. For those of you just joining us, my name is Dr. Pamela Gay. I am joined by Dr. Kim Cartier, who is a science writer working for the American Geophysical Union. You can find her work in EOS and many other places. We are discussing today's space news as part, or not just today's, we're discussing space news as part of our 40-hour-long hangout-a-thon. We are here working to raise money to keep the science and science communications right here at CosmoQuest going. Please consider giving. We are so far behind where we had hoped to be at this point in our fundraiser. Which means if we don't raise enough money, there will be begging in 2020. We really hate fundraising. So if you can help us out, and if you know anyone in your life who has ever said, science needs more funding, well, this is your chance to put your wallet where your mouth is and make science a priority. Now, with CosmoQuest, we helped in our own small way with mapping out Bennu. We're working on software to do machine learning to map out other worlds. And we, as a nation, are working to systematically...
Mouse on Kim's face.
There's not a mouse on Kim's face.
Not anymore.
Sorry, computer mouse. We apparently had a computer pointer that had landed on you. Sorry about that.
I didn't even feel it. It's okay.
All right. We have mice in our house, but I promise they won't be on the webcam.
Yeah.
Or at least we had one mouse once. Looking ahead this year, a lot of our news actually focused on the step-by-step completion of the Rosalind
Franklin?
Yeah, the Rosalind Franklin rover by the European Space Agency and the Mars 2020 rover by NASA.
Sorry.
with all the different stuff going on, what were the milestones that made your heart beat a little faster, and what are the things that you're looking forward to in the future?
Oh, well, things that made my heart beat faster um, were Mars quakes.
Yes.
Oh my God, Mars quakes. With Mars Insight, speaking of Mars things, I don't often get excited about Mars things. Um, I personally enjoy other planets in the solar system, and I'm sort of tired of hearing about water on Mars. So Mars news like doesn't always get me going, but
Yeah.
Mars quakes, just like listening to the first signal of a quake on Mars. Um, I played it on repeat on YouTube probably like 100 times in a row. That was just so fascinating. And I actually wrote a whole feature article about it, going really in depth with the Insight team and the team that built the seismometer on what it actually takes technologically and scientifically to detect a quake on Mars and
Yeah.
figure out where it came from, figure out what it is, and why it might be. Like, why is Mars quaking? That's one of the main scientific goals of InSight. Um, and from that, I think two of the cool things from that um, are one, on Mars, we're detecting quakes that we could never ever detect on Earth.
It's true.
They are way quieter, way weaker than anything we can actually detect on Earth because Earth is essentially contaminated with all this movement of oceans and atmosphere that raises the noise level
Yeah.
such that we can't detect the tiny quakes that we know are probably going on Earth, but we can never detect them. But we built a detector sensitive enough to detect it on Mars, and that's what we're seeing. And the second really stunning thing um, that I learned about that was before InSight landed, the team had predicted a place on Mars that they thought was going to be a source of quakes, an active area kind of nearby called Cerberus Fossae. It's a young lava field that they think has been recently seismically active. They placed InSight down, and two of the first quakes that they detected came from that region. So cool. Like predictive science. It's awesome.
Now, one of the things that I've been wanting to ask an insight person, and maybe you've had that opportunity. They have these two contradictory instruments that aren't supposed to be contradictory. So you have the seismograph that is looking to shake. And then you have the mole that was meant to very quickly burrow itself and then sit there and detect things. But the mole like refuses to go all the way down under the surface. They're having some problems
Yeah.
there. And so they've been having intermittent hammering for months. Does this drive the seismograph people crazy because they can't get good data when the hammering is hammering?
Well, I wasn't able to ask that particular question. I'm pretty sure if I did, they probably would have given the polite answer of, we wish the heat probe team all the best, because they're very polite. Um,
Yes.
the the key part of it, I think, is that the two teams are talking to each other a lot.
Yeah.
And so the seismograph team knows when the heat probe team is about to try something, and they can factor all of that extra motion in to their essentially noise cancellation programs when
Right.
they subtract it out. It probably will drown out some of the weaker quakes that they could be detecting, but they've detected a lot of those at this point. Um, they probably want to detect more, but at this point, I think they really want the stronger quakes, and the heat probe probably won't drown out those ones.
Okay.
But the two teams talk to each other. I I think the seismograph team does want the heat probe team to do good things, um, get down into the ground, do their stuff, and then everything will quiet out. It probably does affect some of the measurements.
Yeah. I can just imagine there is at least some grad student somewhere looking at the pictures of the mole going, "Why are you still above the surface?" Heck, I bet there's some of the people
messing up my merge quakes.
Yeah, and I bet that
Reducing
there's
the
also
data.
a graduate student who wants to study the data from the mole who's saying the exact same thing while crying. That would have been me working on my dissertation with an instrument that didn't work.
Yeah, so that was one piece of advice I actually got before going into grad school, which was never tie your dissertation to a telescope that is still in development or an instrument that is still in development.
I had a rocket explode. It didn't explode. It failed to have a second stage burn and reach orbit with an X-ray satellite I was planning to use.
Oh.
And I was using one of the very first generation massive telescopes. And while it saw first light, my plans of getting 15 to 30 spectra per cluster for dozens of clusters became 18 total spectra of all of my clusters.
Yeah, that happens. I know at Penn State, where I got my degree, they were still in development of an instrument called HAT, which is essentially a very large scale multi-object spectrograph for galaxies and the universe.
Yeah.
I don't know, and it was in development before I got to grad school.
I'm laughing because it was a different Hobby Eberly telescope instrument that got me.
Really?
Yeah, because I was at the University of Texas.
Yep. Yeah. They have some stuff. I will say though that during my time in grad school, they finished 2 exoplanet spectrographs. So I appreciated that as an exoplanet person. I bet the galaxies and cosmology students didn't really appreciate the lack of progress on that other instrument. Oops.
So let's go to a happier place. And exoplanets is always a happier place.
It is, isn't it? Such a great
This year we've had so many discoveries. What are the things that stood out for you in exoplanet astronomy?
Exoplanet astronomy. So I think the obvious one is TESS. TESS has been doing excellent science. It reached its 1-year mark this year, 1-year anniversary. It completed the entire southern sky scan, searching for exoplanets.
And I'm going to interrupt you and say, Megalyn73, thank you for tipping the $20. Thank you.
Thank you.
Yay, science!
Yay, science.
Okay, continue discussing exoplanets.
Exoplanets, planets around other stars, my heart's desire. TESS has been doing excellent work, and I think the one of the data products that came out was that beautiful all-sky map of the southern sky with all the discoveries and the band of the Milky Way and the large and small Magellanic Clouds, which I'm a geek, so I stared at that for a good hour, picking out things that were interesting. So TESS, what more could you want with TESS? It's great. So that happened this year. Chaos launched just last week, the week before.
Yeah, it
basically
did it actually make it off the ground?
It did. Yeah.
Okay, then yes, it was last week because I remember the day that it was supposed to launch, it didn't. And then I lost track of whether or not they actually launched it.
I think they did. I hope they did.
I'm checking if they did. Chat?
I think it did.
Anyone know?
It's not in place yet.
Launch December 18th. Okay.
18th. Okay. I think it was supposed to launch the 17th, but it didn't.
Okay.
Yeah, this was when I was down for the count sick, so it's not paying attention to anything. So CHAOPS and ESA mission, and I just love ESA missions so much.
Yeah.
They do such great work, and we don't talk about it as much over here in the U.S., but ESA missions, they do really, really great work in areas that NASA doesn't, and in areas that Japan's space agency doesn't. Just excellent stuff. And CHAOPS, is doing a lot of the nitty-gritty necessary science to follow up on all of the exoplanets. So with Kepler, with radial velocity measurements from the ground, you get really good discoveries, but there are oftentimes a lot of uncertainty in each of these measurements. So with radial velocity measurements, which measure the gravitational tug a planet exerts on its host star, you can figure out the mass of a planet, but you don't know its size. And you really need both the mass and the size in order to figure out if it's a gas giant planet or if it's a rocky planet. And radial velocity can only get you one of those. KAOPS is spending a good 10% of its time following up on radial velocity targets to try and get the sizes of all these planets.
And is it going to have significantly greater sensitivities than, say, HARPS down in the southern hemisphere?
So they're doing different sciences. So with HARPS, you're doing radial velocity measurements. You're taking a spectra of the star. With KAOPS, you're doing a transit measurement. So you're taking an image of the star and looking for the tiny dip in starlight as the planet crosses in front of it. So they're doing complementary science. And it's going to be about as sensitive as Kepler was.
Okay.
Who did similar types of measurements for about 4 years. And so KAOPS and HARPS, both ESA, HARPS is ESA, right?
Yeah.
Yeah, they're going to be doing complementary science. And I think KAOPS is following up on a lot of HARPS targets because they're both going to be looking around bright stars, which is where HARPS did a lot of its work.
And we really do want to look at these systems where we believe there's exoplanets with two different techniques to make sure that we're not actually seeing star spots or something else to verify, it's a
lot
planet.
of the false positive checking. Because there are a lot of things, both with radial velocity measurements and with transit measurements, that can essentially masquerade as a planet.
Right.
And as scientists, we want it to be a planet. We're hopeful. So we find a signal that looks like something a planet would produce. We do all the checking we can with the data we have, but sometimes there's still things that can fool us. And so following it up with a different telescope, with a different technique, all of that can verify whether it's actually a planet or not and give us a whole host of new type of information that can give us a new understanding of what these planets actually physically are. And part of what KAOPS is also maybe going to do is start to look at the skies of these planets, which is something we're only really starting to do a very little bit.
And with all of these new discoveries, we're going from, in the early 90s, asking the question, are planets rare, to realizing there are planets everywhere.
Planets are all over the place.
And we have all kinds of new statistical studies that are possible, but we're still only looking at a subsample of all the stars. We're still only looking at a subsample of all possible kinds of worlds out there. What gaps still exist that we need to fill in?
Oh boy, there are so many gaps.
Yes.
Like you said, we are limited based on the technology that we can build and where we can put this technology in our solar system in order to observe. So I think every so often someone produces a really excellent map of the Milky Way that highlights essentially all the stars around which we have looked for exoplanets. Right. And when you look at that map, the cone or the tiny little sphere that we've actually been able to search is 2% of the entire Milky Way, something ridiculously small like that. For all the thousands of worlds that we found, it's such a small fraction of the stars that actually exist in the Milky Way. So a big gap is just there are way more stars to search, around which to search. Another gap is the types of stars that we're able to look at. We are, because we're limited to, what stars we're actually able to look at, we're looking at a lot of sun-like stars.
Yes.
So things that are about the size, the temperature, the mass of the sun, and also approximately the age of the sun as well.
Right.
We're not looking so much at super young stars, except for a few exceptions. We haven't really done a concentrated search around really old stars, with very few exceptions. And those might give us whole different populations, types of planets that we've never even thought of before. So that's some gaps. We've not actually found a planet just like Earth. Still looking, hoping to find one of those. Haven't found that yet. And despite one really exciting paper this year, we haven't really found any moons. We haven't definitively found any moons around any planets yet outside of our solar system. There was one very promising
hints.
discovery. Yeah, there's some hints, some maybes. Some moons could explain this. And here are 5 other things that could also explain this. Types of discoveries. But if planets exist, then moons should exist too. We've seen hints of comets around other stars, or asteroid belts, or debris, like debris from collisions around other stars. So we know the material has to exist, but we haven't found it yet.
Now,
so much still to find.
Do you have a favorite planet that isn't in our solar system?
Favorite planet. So if I'm going to pick a favorite, it's like picking your favorite pet or your favorite child or something like that.
I understand.
Or your favorite Star Wars movie. There's so many to pick from now. Outside of the solar system, man, there's what is it? It's Kepler. What is it? 1260, something like that, which is the one that maybe has an exomoon.
Okay.
There's one that I know in and out, which is WASP 103, which is a hot Jupiter. That's what I did my dissertation on. I know that like the back of my hand. So love out
you
of
may know it
familiar.
better than the back of your hand.
Probably. I don't really stare at the back of my hand all that often, so I don't really understand that phrase. But and then there are some other really wacky systems like Kepler 296.
I don't.
Random numbers. I'm
Yeah.
not like, if I'm going to pick a favorite, it's not going to be like TRAPPIST system.
Well, so like mine is
Kelt
Kelt 9b, which
Kelt
is
9b. So cool.
Yeah, it's next to a
not.
super hot star.
Yeah.
And the side of this planet that's closest to its star is actually the same temperature basically as the surface of our sun.
Yeah.
And yeah. So Larry's asking WASP 103b, can you tell us more?
Question mark. WASP 103b is a hot Jupiter planet. It is, so that means it's a little bit, about 1.5 times the size of Jupiter. It orbits in about 3.5 days around its star. And it is something like the 3rd or 4th hottest planet that we've discovered. And the reason that I love it so much is that it's one of the planets where we've gotten the most detailed look at its atmosphere. The day side and the night side, we are able to get spectra of the atmosphere to figure out what's in it. I mean, there's not really anything all that interesting in it. There's not really a good signal of water. There's a little bit of carbon dioxide, a little bit of methane, which we're starting to get an idea is pretty standard for some of these hot Jupiters. But it was one of the first we were able to get a really good idea of the atmosphere of these hot Jupiters and to refine our techniques that are going to really help when we launch James Webb for follow-up and for KAOPS when we start to get some of those data back. That's one of the first, and I hope that I contributed some to that science. So it's love based out of familiarity. It may it may not be a flashy one, but it was an important data point on the road towards some of these other discoveries.
There's a Tim Minchin song about this that you should go find. Basically, the idea of the song is none of us have that one soulmate, but given time, memory, and familiarity,
Yeah. It might
it's
have also been a love the one you're with mentality when
right,
it came
right.
to that particular exoplanet. I spent a lot of time on that one. I think my first exoplanet paper was on the Kepler 296 system, which is weird. It has two stars that are smaller than the sun, and it has 5 Earth-sized planets,
Oh,
3 of which may be habitable. And you're just like, what? Who comes up
Tatooine
with
is possible.
it? Is totally possible. Um, there's some of these just like weird systems in the Kepler data where you have 2 or 3 or 4 stars that have multiple planets around them. And it's just like, how do you do that? How do you make such a like why is this a thing? Um, and that was like half the reason I did exoplanets for some of these really weird ones.
And and what I love is we think with the science fiction that we're imagining things at the edge of what is possible, and the universe is just like, humans, you have no idea.
The universe is just like, hold my beer, I got this.
Exactly,
Yeah.
exactly. It's awesome. Um, yeah, the
Yeah.
universe is far more creative than we will ever be. Now, news of this year spanned from robots to exoplanets to star formation and so many other things. As a planetary scientist who does the news, you
Mm-hmm.
still see all the other stuff. I'm an astronomer who sees all the planetary. What
Yeah.
things from other parts of our field have really caught your attention?
Well, there was this really very interesting picture. I don't know if you saw it. There was one picture that came out this year that you may have heard a little glimpse a little bit about is a black hole. Anyone see that picture? Black hole. No.
You're referring circumspectly
Directly to the Event Horizon
to
Telescope.
yes,
Yes,
yes.
that made a little bit of a splash.
Uh-huh.
Um, we hosted at AGU a black hole party. Watch the reveal. What we're all science nerds over there. Had a black hole watching party to see the first image from the event
Right.
horizon of a black hole. Oh my God, my God,
I
that
just
caught my attention.
I feel sorry for the people who are still trying to process the data of the black hole in our galaxy.
Right?
It's
Yeah.
so frustrating.
Yeah. So that one caught my attention. What else? All of the amazing images. Well, okay, sorry. I went back to Jupiter. I was thinking of Juno Cam.
Yes, that is
Sorry.
worth
I'm
noting.
a planetary horse. It's okay. Other things. Galaxies?
So there's been some cool results about the star formation history in the center of our own galaxy.
That's right. There was. That was a while ago, though, wasn't it? I don't remember.
So there's been a series of different stories ranging from new jets, new bubbles have been observed
Oh,
that
bubbles. Right.
are the result of shocks of star formation and
Right. I
jets and the
remember that
black
now.
hole eating things.
You're catching me early in the morning. I don't really
It,
talk. I
it's
don't normally
it.
talk about galaxies this early. Gotta
I
have a
love
couple
that
more cups of
concept.
coffee before I talk about galaxies. Sorry.
That's all right.
And the
Now,
planetary stuff is so embedded in my brain. I don't even need coffee. I feel like sometimes I talk about it in my sleep, just feel like, oh, it's Uranus and Neptune, which We should go to Uranus and Neptune, by the way, if anyone is curious.
Right. Now, so the problem, flyby or orbit.
Both. But
Now,
I want orbit, personally. Let's orbit
and,
like Cassini, but better.
and here's the thing. I had this realization the other day that if we send something with a reasonable orbit to a reasonable trajectory to allow it to have a not horrific delta V requirement to enter orbit, it's probably not going to get there in a rational amount of time to enjoy it in the prime of our careers. Because Uranus and Neptune are...
It'll take a while.
It will take a while to get out there, and you don't want to fast pass it the way New Horizons went as zippy as it could to get to Pluto. Because if you're going that fast, how do you dump all of that energy to enter orbit around Uranus or Neptune?
So I'll actually say I have an answer to that.
Okay, thank you. Again, astronomer, give me hope. Give me hope.
Okay. So actually very recently, just before the AGU's meeting a couple weeks ago, I spoke with Mark Hofstetter, who is at Jet Propulsion Laboratory and who is one of the leading voices towards a mission for Uranus and Neptune.
Okay.
Essentially being like, what would be your dream mission to one of these planets? And one of the things that he mentioned also was a technique, a type of aerobraking.
Okay.
Where essentially the spacecraft, as it approaches the planet, in order to slow down enough to get into orbit, it deploys what he called a skirt. Okay. Essentially like a giant umbrella.
Right.
Around the spacecraft, which would slow it down by capturing some of the atmosphere, some of that atmospheric drag. It would slow it down enough to get into orbit, and then it would jettison the skirt or the umbrella afterwards. So the technique they're looking at is aerobraking in order to do that, as opposed to firing jet thrusters. I should put a caveat that they're not actually designing a mission at this point, but they're exploring different technologies that may enhance one of these missions, or essentially take the type of thing we had with Cassini, which is very tried and true, and bumping it up to the next level.
They're developing the technologies we're going to have.
Yeah, that could launch in 10 years or so. Something like that.
Yeah.
I think the optimal window for launching to Uranus and Neptune is about 2030, or starts in 2030. And that's where you get the optimum launch window, so you can fly by and do gravitational slingshots with Jupiter, with Saturn, to shorten your travel time. Essentially, if you launch any later than that, you're going to miss those opportunities. It's going to be, like you said, a way too long of a journey for us to enjoy the science afterwards. Maybe the next generation of scientists will enjoy that, but I want to see it. I want to go to Uranus and Neptune.
I understand. Now we have coming in on the chat one of my favorite thought experiments, and that is a black hole passing through our solar system.
Oh boy. Where?
Well, just like in general, let's fling a black hole through our solar system. Imagine something maybe a 6 solar mass black hole, just a little stellar guy. How would we know if a little black hole was on its way in?
Well, depending on when it came through and from what direction it came through, it would first have to pass through the Oort cloud, which might send in a shower of comets.
Yes.
That we're not expecting.
And the flickers of gamma rays.
Yes. So that might be a clue. Let's make it simple. Let's assume it's not coming from behind the sun. So we can let's assume that we could see it or its effects while it was coming in. We might see it gobble up some stuff and emit some radiation that we're not expecting from that part of the solar system. We might see it knock a couple things out of orbit. Hopefully, it doesn't eat a planet. We hope. Uh, what else would it do? It would eat things, and it would gravitationally knock stuff out of the way.
And
right?
one of the things that we don't think about very often is crossing time really matters. How fast is this interaction? So if a 6 solar mass black hole zips through our galaxy, its gravity won't interact with the planets at a short distance for a lot of time. And so things will get their orbits deformed, but not massively.
Get a little wobble, maybe.
Yeah, we get in a whole lot of trouble if
I was thinking like the slow lurking approach, and like slowly.
So if it's something that's in a super similar orbit around the galaxy to us, so that it's just like barely passing through, that would cause issues.
Yeah, I was thinking the doomsday scenario of like the slow looming approach of this black. It's the mood I'm in.
That's fair. That's fair.
I was going for the doomsday scenario of that.
Australia is literally on fire right now.
It is true. Yeah, it is. You can see it from space and everything. It's kind of really horrifying.
Yeah. A black hole sometimes seems like an improvement.
Sometimes. I suppose I could hope for one of the zippy ones.
Yeah.
Zippy black hole. But my brain, I feel like it says something about me that my brain automatically went to the doom and gloom, slow approach of the black hole to our solar system, like the Death Star approaching Alderaan or something.
So
again, I have something on the brain.
So also Star Wars fan. Although I recently rewatched the first 3 numbered movies. So the middle 3 that were created, where you have Padma and Anakin interacting. Yeah. And then I watched Star Wars. So I watched them in the order that they would be in a history book. And I had this realization that young Jedi are emo as all get out. And I just kind of wanted to go, stop whining. Anakin is the whiniest individual.
Yes, he is.
Anyways.
Yeah. How do you, part of it, I think, is Obi-Wan's fault for raising a child to be that whiny. Kind of a little bit his fault. But it's really not. I'm gonna put it all on Anakin. It's all whiny.
You essentially had a child raising a child, because Obi-Wan was...
He was like 24, 25, something?
Well, but I don't know if he was even that old. He had just become a Jedi Master. And he wasn't even a full master when he took on... His old
master died.
Right. So...
That'd be really... Like, if you were to get a PhD through that method, like, oh, your old advisor's done now. You get a PhD. Like, but I didn't even do anything.
Yeah.
That's not how graduation works.
Yeah.
The whole system is messed up.
But one of the things unrelated to the whininess of the young Jedi, the Death Star is 160 kilometers across.
Sure.
Canon. Random piece of information. I want to calculate its self-gravity, because Bennu is 500 meters across. Yes. And while the Death Star is largely hollow, if you simply treat it like it has the density of your typical skyscraper, it's going to have a great deal of mass. And this is something I now want, like, how screwed up is the gravity inside going to be when you factor in all the accelerations, the self-gravity, and everything else?
So, first thing I'm going to say is that I'm 100% certain that someone on the internet has already done this calculation. I'm sure it exists.
True. That is probably true.
And I think the canonical answer, from my vast knowledge of Star Wars, is that there are specific machines within the Death Star that regulate the gravity so that it's probably Coruscant normal.
I know,
Right.
but those break
Yeah.
sometimes, I'm sure.
It's Deus Ex Machina. There's a fictional
Yeah.
machine that fixes the gravity for you.
Yes.
Yeah.
But we've now strayed far away from science news, and our hour is winding
Oh,
down.
that's true.
Do you have any parting news that you want, or thoughts or ideas that you want to leave our audience with on this early Sunday morning?
Well, the year is winding to a close. There has been some excellent science news coming out of all corners of the world and beyond that we've seen for the past year. There are a whole host of ongoing space missions, and there's also some excellent space missions to look forward to next year. Space news that's going to happen from uh, from the low Earth orbit, from the International Space Station, from the moon. Let's not forget that China's on the far side of the moon. Sorry, I
We
almost slipped,
all
but I
make that
didn't.
mistake. We put so much
I'll do it
effort
all
into
the
making
time.
sure that people understand, and then we screw it up.
Let me screw it up. Yeah. Um, there's Juno over at Jupiter. We're looking towards missions to go to Europa. We're looking at a mission going to Titan around Saturn, which
Yeah,
I didn't
Firefly.
I didn't geek about, but I could have very easily gone off on a dragonfly tangent. Um, and and of course, looking at exoplanets, looking at the Milky Way, looking at the billions of galaxies beyond our own Milky Way. So if in 2020 there's ever a moment when you're feeling down by some more local news, go look out into space. There's excellent and mood lifting things happening over there. It always brings a smile to my face to go to the Juno Cam Twitter account and just look at
Yes.
amazing pictures of Jupiter.
Yes.
If you're ever feeling down in 2020, that's a great way to make yourself feel better because we've never stopped in our search in our the ways that we're trying to discover our place in the universe, and that's how I want to leave the decade, and that's what I'm looking forward to. It's just
I
our continuing search for discovery.
I think that is an excellent way to think about it and to look forward to the future.
Yeah,
Um,
there's great things happening.
so where can people go to find more of your work?
Where can people find out more? I am on Twitter because I feel like you sort of have to be.
Yeah, it's
Um,
true. It's true.
on Twitter, I am at Astro Kim Cartier, Cartier, like the diamond, but really not. It's the French explorer who discovered Canada. That Cartier. Um, and all of my science writing that I do is on eos.org. That's eos.org. I publish there pretty regularly. So hopefully I'll see you there or on Twitter. Come say hi.
That is awesome. So thank you. Please go get yourself a brunch, a new coffee,
I'm gonna go get a refill on coffee.
and um, may the force be with you.
May the force be with you, Pamela. Happy holidays, happy new year. Donate to
Mm-hmm.
CosmoQuest.
Thank you. Bye-bye.
Bye.